Welcome to The Explainer. Today we're doing something really cool. We are stepping inside the hidden, almost cinematic world of mass production. Picture a premium megafactory documentary. Massive stainless steel halls, synchronized robotics, and breathtaking scale. We're looking at the high-stakes engineering behind something sitting on your desk right this very second. Millions of us click or uncap this exact product every single day, expecting a totally flawless flow of ideas. But the reality of how it's made, it is absolutely mind-blowing.
You see, what you probably think of as just a simple, everyday writing tool goes through a frankly brutal industrial gauntlet before it ever reaches your hands. Our source describes it perfectly as a, quote, micro-machined ballet of fluid dynamics and heavy metallurgy. I mean, wow. To get that perfect, frictionless glide, you're looking at a manufacturing process that operates on tolerances literally thinner than a human hair.
Moving into Section 1, Forging the Perfect Sphere. Imagine an ultra-macro slow-motion camera shot deep inside one of these immaculate production halls. It all starts with raw tungsten powder being superheated and forged under immense pressure. But just making a tiny metal sphere? Yeah, that's not good enough. These spheres are thrown into a high-speed abrasive gauntlet, a centrifuge filled with diamond paste until they hit this flawless, mirror-like finish. They have to emerge microscopically perfect. We're talking hard enough to physically punch through steel, but polished so incredibly smooth that they just glide across a piece of paper without catching a single fiber.
And this is where the precision gets truly wild, 0.001 millimeters. That is the exact microscopic gap required between the tungsten ball and its brass socket. A custom, AI-guided milling machine forms the seat, drops the polished ball in, and mechanically crimps the edges to lock the whole thing in place. It's this hypnotic, high-speed fluid control choreography. If that gap is even a fraction too tight, the pen scratches. If it's too loose, that super thick, viscous dye is going to violently leak everywhere.
So how do they guarantee every single click gives you a perfect skip-free line? It requires an absolute symphony of high-speed robotics. See, once the ink is injected, air bubbles become the ultimate enemy. To stop an airlock from ruining the flow, every single cartridge is spun in a massive high-speed centrifuge. At the exact same time, robotic sensory machines are literally dragging these pens across miles of paper in endless figure eights just to test the flow rate. Then, pneumatic mechanical arms assemble the retraction springs and apply these pristine, sonic-welded permanent seals.
Now, to really grasp the mind-bending scale of this operation, we have to look at China. In 2017 alone, they manufactured a staggering 38 billion ballpoint pens. That's 80% of the entire global market. Just one production line in these sprawling automated megafactories can mold, fill, and test over 2,000 pens every single minute. To put that into perspective, if you took just a single day's production and used them to draw a continuous line until they all ran dry, that ink trail would wrap around the entire Earth multiple times. It's just staggering.
Impartially speaking, operating at that kind of massive scale actually drove a huge industrial milestone back in 2017. Up until then, a lot of the highly complex metal alloys needed for those precision tips had to be imported from Europe and Japan. But Chinese state steelmakers, specifically the Taiwan Iron and Steel Group, or TISCO, spent years researching and finally cracked the code to produce these high-grade steel alloy plates domestically. It basically created a completely self-sufficient supply chain for these ultra-precise components.
All right, let's step out of the modern megafactory for a second. Section 2, A History of Fluid Dynamics.
The messy, centuries-long historical struggle to conquer gravity and get ink onto paper is honestly fascinating. We started out in 3000 BC in Egypt, literally dipping sea rushes into ink for papyrus. Fast forward to 1636, and inventors in Germany are sealing ink inside double quills with cork. But the big leap happened in 1888 in the US, when John J. Loud patented a rough steel ballpoint. Now, he actually just wanted something to mark coarse leather, not paper. It was a brilliant idea, but the execution was just way too rough for writing letters, so his patent eventually lapsed.
So, before the ballpoint could truly take over, we relied on the fountain pen. And fountain pens are beautiful, right? They rely on a delicate physics principle called capillary action.
That's basically the ability of a liquid to flow through narrow spaces without any help from gravity. It pulled this water-based ink down a specialized feed right to a gold nib. Super elegant, but man, was it high maintenance. If the temperature shifted or, say, the air pressure changed, you were almost guaranteed to end up with a shirt pocket totally ruined by ink.
Which leads us perfectly into Section 3, the ballpoint revolution.
So here's the crucial turning point. Early engineers were desperately trying to fix the ballpoint, but ink delivery was a total nightmare. If it was too thick, it clogged. If it was too thin, it leaked everywhere. But then, modern chemistry stepped in with a highly viscous, oil-based formula. It dried instantly, and you didn't have to constantly refill it. When they paired that super thick ink with a perfectly rolling, precision-machined tungsten sphere, everything changed. Suddenly, you had a low-maintenance tool that just worked.
Wright's first time, every time. That was the brilliantly simple marketing hook in the 1960s from Marcel Bisch. He basically took all these massive engineering victories, shortened his last name to BIC, and created the disposable Bic Cristal. By leveraging mass production, those endless conveyor networks pumping out perfectly calibrated plastic tubes, he brought the unit price way, way down. It democratized writing, making the Bic Cristal the most widely sold pen in human history.
All right, let's jump to the modern era. Section 4, Extreme Pens, Tactical and Beyond. We've gone way beyond just taking notes. Today, combat designers are using materials like lightweight, weapons-grade polymers and solid titanium to build discrete force multipliers, like the Stealth Pen Pro. The whole idea is to concentrate the force of a physical strike onto a tiny point. To do that safely, they use incredibly advanced CNC machine finger grooves and knurling for grip, plus a flat top end so you can stabilize the pen with your thumb. And the best part? The styling is so non-aggressive you could carry it every day and nobody would even look twice.
But you can't just slap knurling on a pen and call it tactical. It has to survive what's called the wet hand strike test. This is a brutal physical gauntlet. You literally strike a wooden post 10 times with wet hands. If the pen slips in your grip, or if it hurts you, it completely fails. And here's the real kicker. After taking all that extreme impact, you have to be able to uncap it and smoothly write your name. That internal ink cartridge has to survive the shock perfectly. It's an incredible engineering standard. And the fluid delivery technology itself is evolving just as fast. We've largely moved on from standard oil-based pastes to these really vibrant water-based gel suspensions that give you those opaque colors on dark paper. But the absolute cutting edge? Pressurized nitrogen reservoirs. By actually injecting gas right behind the ink column, the pen forces fluid forward against the ball bearing, completely defying gravity. The ink never starves, which means, yeah, you can literally write upside down or even underwater in extreme environments.
So, the next time you hear that totally satisfying click, I really want you to ask yourself, are you just holding a simple plastic tube, or the ultimate triumph of industrial precision? I hope this explainer has completely transformed the way you look at that microscopic silver sphere sitting right there on your desk. It really is a masterpiece of fluid dynamics, a violent, chaotic process of heavy metallurgy, beautifully tamed into a state of perfectly smooth utility. Thanks for hanging out with me to uncover the hidden engineering miracles hiding in plain sight.